Dear students, very good morning. Today we are going to see some important series under the topic complex integration. The topic complex integration. So under topic complex integration, we are going to see some important series. Some important series. See, the first series we are going to see is Taylor's series. The second thing is Laurent series. And as a special case of Taylor series, we will have Maclaurin series. That is Maclaurin. Maclaurin's series. So these are the series. So I can call it as first series, special case of first series, and second series, or simply you can call it as first series, second series. If I take it as second series, you can change it as third series. It is all about your wish. Okay, now the expansion of Taylor series. The Taylor series expansion is given by a function. First of all, a function f of z is analytic inside a circle C. Okay, right? A function f of z analytic. This function is analytic. A function f of z analytic inside a circle, C with center A can be expanded as f of z equal to f of a plus f dash of a by 1 factorial into z minus a plus f double dash of a by 2 factorial into z minus a the whole square plus f triple dash of a by 3 factorial into z minus a whole cube plus etc. plus f power n of a, that is nth derivative of f of a, by n factorial into z minus a whole power n plus etc. Okay, so this is the expansion of Taylor series, which is convergent at every point inside C. At every point inside C. Now what is this series? This Taylor series is about the point. See, this Taylor series is about the point z equal to, this Taylor series is about the point center A. Okay, so we can call this as Taylor series about Z equal to A. We can call this above expansion as Taylor series about upon Z equal to A. That is f of Z equal to f of A plus f dash of A by 1 factorial into Z minus A whole power 1 plus f double dash of A by 2 factorial Z minus A whole square plus etc. plus nth derivative of f of A by n factorial into Z minus A whole power n. If I take it as Z equal to 0, that is Taylor series about Z equal to 0, that is A into 0. I am taking A equal to 0. So our f of Z will become f of Z equal to f of 0 plus f dash of 0 by 1 factorial into Z minus A, it will become A equal to 0 means it will become Z plus f double dash of 0 by 2 factorial Z square plus f triple dash of 0 by 3 cube Z cube plus etc. plus nth derivative of f of Z about A, Z equal to 0. So f power n of 0 divided by n factorial into Z power n plus etc. This Taylor series about Z equal to 0, that is A equal to 0, is called Maclaurin series. Maclaurin series. Maclaurin's series. Okay. Next we are going to see about Laurent series. Okay, Laurent series. Laurent, Laurent, Laurent series. Okay, here we want to define two circles. The circles are concentric circles, so we will have two circles. So if C1 and C2 are two concentric circles, concentric circles, modulus of Z minus A equal to R1, and this is radius 1, then modulus of Z minus A, sorry, this is region 1 and this is region 2. Okay, C1, C2 are two concentric circles, and this R1 and R2 are regions R1 and R2. Okay, and both R1 and R2 will be same. Okay, since they are in between the concentric circles, so both of them are sharing the same reference side. Okay, but what is actually going to happen is, since even though they are sharing the same left hand side, we are defining it as that R2 is less than R1. The R2 is less than R1. Okay, now I am again assuming, let f of z be analytic. F of z be analytic on two concentric circles C1 and C2, and also in the annular region, and in the annular region capital R. Annular region means regions between the region enclosed by two concentric circles. The region between two concentric circles, between them, that is between C1 and C2, between them. Then for any point in any point z in R, we have the Laurent series expansion as f of z equal to summation n equal to 0 to infinity an z minus a whole power n plus summation n equal to 1 to infinity bn divided by z minus a whole power n, where an is given by 1 by 2 pi I into first circle C1 f of z divided by z minus a whole power, here n is positive, z minus a whole power n plus 1 dz. Okay, z minus a whole power n plus 1 dz, and bn equal to 1 by 2 pi I integral over C2 f of z divided by z minus a whole power minus n plus 1. Okay, that is 1 minus n plus 1 dz, comma, the integrals being taken anti-clockwise. See, here it is, since minus n, the intervals are being taken in anti-clockwise. In the integrals being taken anti-clockwise. Now to understand this, let me tell you this with an diagram. So I am having a point here and I am going to have a circle. Okay, this circle is C2 and I am going to have another circle with the same center, so this circle is C1. The region between C1 and C2 is called annular region or and this A is the center and this A is the center. Okay, now they have given the distance between 2 points R1 and R2. So here they have taken R2 is less than R1. So I will take this to be R2, R2 region, R1, R2 is the region covered by modulus of Z minus A. That is most probably it will be radius, and this will be R1. Now the region covered from Z minus A equal to R1 is more. Okay, whereas Z minus A equal to R2 is less. So this is the region. They does not mean the radius. They also mean and region covered by radius. Okay, region covered by radius. Okay, now I am considering a small point, that is a small z inside the annular region, and I am going to draw a circle. I am going to draw the circle of radius rho. Go to draw the circle of radius rho. So what is radius? It is very small radius. Radius equal to rho. Okay, then this small circle is called gamma. This small circle is called gamma. Okay, so after expanding this figure and explanation and after some derivation, we will arrive at this formula, this Laurent series formula. Here we are taking an multiplied by z minus a whole power n and bn divided by z minus a whole power n. So I can write this f of z as summation n equal to 0 to infinity an z minus a whole power n plus summation n equal to 1 to infinity bn into z minus a whole power minus n, bn into z minus a whole power minus n. Okay, so it will come to denominator. That is what given here. See, you please remember this formula. An is multiplied by z minus a whole power n, bn is multiplied by z minus a whole power minus n. So since it is multiplied by z minus a whole power plus n, we can take n equal to 0 to infinity, but we have to make this to come to the denominator. So if I put n equal to 0, the coefficient of both a and bn are same. Actually, a and bn are the coefficients of z minus a whole power n and z minus a whole power minus n, but they will become equal. So in order to avoid that, we have to put n equal to 1 so that it will come to denominator, z minus a whole power minus 1. It will come to the denominator. So the value starts from plus 1. Okay, where an equal 1 by 2 pi I integral over c1 f of z minus c divided by z minus a. Since n is positive here, we take n plus 1, whereas in bn we are having 1 by 2 pi integral over c2 f of z by z minus a. Since n is minus here, we are having minus n plus 1 into dz. Okay, so this is Laurent series. So we are having Taylor series and Maclaurin series. Okay, the Maclaurin series is nothing but if the Taylor series is about a point z equal to 0, that is when a equal to 0, we will get Maclaurin series. So Taylor series is about a point z equal to a. If Taylor series is about a point z equal to 0 means it is Maclaurin series. And in the same way we will get the Laurent series. In the same way we will get Laurent series, but we have to assume two concentric circles C1 and C2, and the integration also depends on them. Integral C1 and C2. Now there are some notes we have to keep in mind on this. The notes are if f of z is analytic inside the concentric second circle C2, then the Laurent series reduces to Taylor series of f of z with center A. Since in this case, since in this case all the coefficients of negative powers in Laurent series are zeros. The second note is we call summation n equal to 0 to infinity a n into z minus a whole power n, consisting of positive integral powers of z minus a. This is integral. Z minus a is called analytic part. Of Laurent series. In the same way, the summation n equal to 1 to infinity bn into z minus a whole power minus n, consisting of negative integral powers of z minus a is called principal part. This principal part of Laurent series. The third note is Taylor series expansion Yes, Taylor series and Laurent series expansion in the given region are or unique. They are not usually they are not necessary to be found by the formula theorem also. That is, Taylor series theorem represents Taylor series expansion. Laurent series theorem represents Laurent series formula. So we can write theorem also by the theorem, but simply we can use the binomial series. Okay, to derive the same result. Now the last note we know Taylor series about z equal to 0, that is a equal to 0 will implies Maclaurin series Maclaurin's series. In the same way, there is another note there is no negative powers of z minus a. There is no negative powers of z minus a. Okay, I hope you all understand the problem. So you have all understood the formulas and concepts. Okay, so we will get you on different concept tomorrow. Thank you all for watching this video. Thank you all once again.